All right, so we're going to talk about the types of chemical reactions first. This is going to be like an overview or a general way to recognize the equations, okay? We're going to talk more specifically about each one, of course. The first type, there's 5 main types. First type we're going to talk about is called composition or synthesis. Sometimes you might see it as combination, but basically you're going to start with 2 things and make 1 thing. So you're going to, a general formula is going to be A plus X is going to make AX. So we're composing it or we're synthesizing it. When we're doing this little key, we're going to use A and B to represent metals, and we'll use X and Y to represent nonmetals, just as our little code there. Okay? So one of the ways that you will recognize the fact if it's a composition or synthesis reaction is it will always only have 1 product. So if you see that it's only making 1 product, that's your clue to say, hey, that's a synthesis or a composition reaction. Okay? So if a composition has 2 things and it's making 1 thing, what do you think a decomposition is? It's exactly the opposite. Now we're going to decompose it. So we're going to start with 1 product, okay, and we're going to break it down into 2 simpler products. So it'd break down. And so you would recognize the fact that it's decomposition by the fact that it has 1 reactant. Okay? A single replacement is exactly what it sounds like. You're going to have an element and a compound together. So there's 2 kinds. You can single replace a metal with another metal or single replace a non-metal. So we're going to go with the first one of A plus BX, and then it would go to AX plus B. So basically it would replace the other metal. Okay? Or if you were doing metals, non-metals replacing non-metals, you could do Y plus BX, and then you would get BY plus X. So basically kicking the other one out, okay? The way you recognize this one is you will have an element plus a compound on both sides. So that's one way to, I'm going to abbreviate compound there because I'm running out of room. Okay? A double replacement is going to replace 2 things. So basically they switch partners. It's like they're doing the do-si-do here. So we would have AY plus BX, and then on the other side you would get AX plus BY. Everybody switches partners, and you would recognize that by the fact that you have 2 compounds on both sides. And these are just general ways for you to recognize the type that they are. If it's asking you what type it is, it's by no means going to help you predict what it's going to make. There's specific rules about that. And then the last one is combustion. And combustion is going to have a hydrocarbon, so we're going to do C, and we're just going to do a number here, and H and a number. Sometimes you can have an oxygen in there, but it's always going to be plus oxygen. And these are the easiest ones to predict what they make because your combustion will make CO2 and water. Okay? And we recognize those by the hydrocarbons. And they can have various numbers. So that's the way you can recognize those. Okay? Any questions on that? Okay. Well, then let's try to at least get through composition or synthesis reactions. Would like to get through decomp. That way, I want to try to get through all the examples so then we have more time in class to practice because then I can answer questions. All right. So composition are 2 or more simple substances, elements or compounds combined to form one more complex one. Okay. And of course, we said a while ago we recognize that by the fact that it only has 1 product. So if it's making 1 product, it's composition or synthesis. I don't care which one you call it. I like to call them composition because then I can recognize that decomposition is the opposite. But you can call it whatever one you prefer. Sometimes some teachers and some people call it combination because you're combining them. So whatever works for you. Okay? So a couple of things to go through. These are all listed in your notes. We're just going to discuss the types of composition reactions that you might see. First one is the very simple one of group 1 and 2 metals will combine with a non-metal to form a salt. Okay? And when we say a salt, we don't just mean sodium chloride. A salt is a class of compounds. Basically, any of the ionic compounds can be considered a salt. So then you're just going to put them together and match up their charges just like you normally would. okay? So magnesium by itself is 0, but when it's in a compound, it's a group 2 metal, so what would its charge be? +2. And so, and then chlorine normally would be 0, but when it's in a compound, it's a -1. So then you would put the compounds together in the way that you know that they go together. Hold on one second. Okay, so when they're by themselves, of course, they're not going to have charges, remember, but when you put them in a compound, put them together in the way that you know that they go together, that's why we've been practicing writing formulas, okay? Two nonmetals, if you react two nonmetals, they're probably going to form a molecular compound, obviously, because that's what they would form. So then you would have to kind of know what's going to do. CO2 is usually going to come from C and O2, okay? Some other examples of that, two compounds may form a single. So here I had SO3 plus CaO, and it actually is going to make CaSO4. Okay, it's still going to make one compound, so it's still going to be a composition. And then a metallic oxide plus water will form an acid. I don't know why I said acid. That's not supposed to be an acid. That is a mistake. That is hydroxide. I am so sorry. Please make that note change in your notes. Form a hydroxide. It's actually going to form a metal hydroxide. So please fix that. Okay. Then the last sets are a metallic oxide plus carbon dioxide is going to make a metallic carbonate. So again, you would put those together based on their charges. A metallic oxide plus sulfur dioxide would yield MgSO3. And a non-metallic oxide plus water, that one would yield an acid. Okay? So those are the basic types of composition. So you'll need to refer back to your notes when you start doing these so you can predict what they make. Okay? And then guess what? Decomposition, that's why I want to do them at the same time because they're basically the opposite of what we just said. They break down now. Okay? So decomposition, we're going to recognize that it's going to have one reactant and it's going to break down into two simpler substances. So you'll recognize decomposition by the fact that it's got one reactant. And it's the only thing that will have just one reactant. So it'll have, like, say, H2, O2, and then it'll have the arrow after just one thing. So the only thing it can do is decompose. It can't react. So it's just going to decompose. Okay? And then there are examples of those. So a while ago we said if we have a metal and a nonmetal, we would form an ionic compound. Well, guess what? If we have an ionic compound and we decompose it, it's going to break back down into a metal and a nonmetal. So they're basically exactly opposite most of those things we just did. So I'm going to have y'all read through those on your own because you can read those and figure those out because it's basically taking what we did and flipping it. Okay? So I'm not actually going to give you the paper until tomorrow because it's all mixed in. So what I would like you to do today to help you understand this is do the left side activities for both composition and decomposition. That'll help you practice. I'm going to tell you this, you're getting a lot more practice than the other class. So please take advantage of it. Okay? I think that's where we want to stop for today. Yeah, we'll pick up with single replacement tomorrow.